All right, if you're doing this round, you probably already took Algebra 2 in a previous year, so you know all of the material there is to know here. So this bit is probably going to be just more advice than anything else. Check your answers, okay? You get an answer, but check to see if it makes sense. Plug it into the original thing or whatever, plug it into the original story, make sure it makes sense, because they will trick you like that a lot of the time with dummy answers that don't actually work when you plug them in. A lot of time with the absolute value problems in here. Be aware of sign switches. X could be positive or negative, there's a lot of those. When in doubt, you can always assume that both of them work, and then check them and see if they actually work in the original thing. And be aware at any point that X may be a negative number. Alright, that affects how sign switches happen. Like if you divide by X, you may or may not have to switch the direction of the inequality symbol. You would probably do both and then solve each one and see, and then plug it in the original, see if it works. Read the question again when you're done and make sure you've actually answered the question, because a lot of times it'll be like, what's the sum of the answers? Because if they say, what are the answers, some people will write like two different numbers in one way, some people will write two different numbers in a different way. By saying what's the sum of the answers, they can figure out if you found the answers and added them up correctly. And that's that's a lot simpler for them to grade. They don't have to be like, hold on a second, I'm not sure if this... Right. And there's usually somewhere in the round a quadratic equation, and they're usually factorable. Use the formula only as a last resort, the quadratic formula. Let's see if there's a good example here that I can do. Oh, looks like I put it over there. Here we go. Compute all values of x that satisfy x minus 1 over x is greater than 2. So you would start off by multiplying each side by x, right? So that x minus 1 is greater than 2x, except that x might be negative. So you should separately write x minus 1 is less than 2x. And then you solve both of these things. You solve this. Now this is if x is negative, if x is positive. And they want all solutions. I'm going to finish solving this. I'm going to subtract x from each side and get x is less than negative 1. Well, that's not the case. Right? If x is positive, then x must be less than negative 1. That's not the case, we can rule those out. If x is negative, subtract x, x must be greater than negative 1. So we need numbers that are negative such that x is greater than negative 1. So that would mean, on the number line, all the numbers between negative 1, not inclusive, and 0. Now they will not, and note that 0 is not a negative, right? What if x is exactly 0? Well, then you're dividing by 0, you can't do that. So the only solutions are between negative 1 and 0. Okay, one thing of note here. They don't want you to draw this. You can either write, this is a pain in the butt, don't do this. You could write all the numbers between negative 1 and 0, not including negative 1 or 0. That won't fit on the answer sheet. Or you can write the answer in what's called interval notation. You say all the numbers between negative 1 all the way to 0. If you wanted to include 0 instead, you would write this. If you also wanted to include negative 1 in the set of solutions, you would write this. This means not including either end, this means including both ends. So this is like closed circle, this is open circle. That's interval notation. I know it looks like a point, but in one dimension, that's how we write it. Okay, that'll do.